Hi, this is John Miller with Internetic. Recently, we got the scam reported to us, and I wanted to just kind of dive into it as a bit of a challenge myself. This video is going to be a deeper dive than we usually do. Normally, we kind of surface level, and we don't go into like how the code works and such. So this one, I'm going to challenge myself. I haven't worked with this one before. I'm going to try to take this apart, kind of live in quotes. It's recording, obviously, but kind of live, without really seeing it before. Also, I'm going to do as little editing as possible, so I apologize if there's any background noise and such. We're in a new office. I don't have the sound dampening all that yet, and I have a window now. So we got this email. It came from Catholic McMullen to one of our clients, and it's actually not obviously, this one's fairly well put together. There's no visible spelling errors, weird formatting, the normal stuff you go, this looks fake. It came from one of their vendors. I've edited out all the sensitive details. I'm not going to name and shame. It just came through, so we're going to take a look at it. So Kathleen McMullen, who it did come from, it looks like came from her actual email address, so very likely her account has been compromised. And I'll be reaching out to her later on to look at that. I've edited out the to and all that stuff for sensitive details. So it came in, and it looks like a past due invoice of some variety. It's kind of vaguish enough to not really go, hey, this is not mine. I didn't buy this, obviously, like an Xbox or a PlayStation, whatever. The standard Amazon or PayPal scams you see. This one is kind of a business-oriented one, where it went from a business to another business as a vendor says, hey, your whatever is overdue. Though, also, this is a snipping, so I don't have the actual email in front because I didn't want to play it in my live system. So we got view and pay invoice. If we did mouse over, it would show this case. It actually went to a Google Drive. Sorry, what's it called? A Google Drive. What do you call this? I'm actually blanking on what's called now. A Google Drive. Let's go with that. It goes to a Google Drive, and it downloads an HTML. So this is kind of, it's not a new thing, but it's an interesting little thing because almost every company has Google Drive available. In general, it's best to block any service you don't use or you don't do business with. Unfortunately, it's not so much unfortunately, I make it sound like it's a bad thing, but it's one of those security things where you have to balance convenience versus security. The more secure you make something, the less convenient it is. The more convenient it is, the less security you can put in place. So you keep having to balance those. In the IT world, we call those a CIA triangle. CIA meaning confidentiality, integrity, and availability. You can't have all three. You kind of have to move your availability, your confidential, integrity. Confidentiality meaning, is it hidden? Integrity meaning, is it safe from editing? Availability means, can you get to it? You need to get to it. So it's like the old adage, quick, safe, and clean, something like that. I'll think of it later. The general idea is you have to have some openings in your security to do business. Unfortunately, you can't just be in a vault and make money just sitting in that vault alone. You have to have these things open in some cases. In this case, Google Drive, things like Google Drive, OneDrive, SharePoint, for a business to do business, they have to have those open, unfortunately. So in this case, the scammers are playing on that. So if they've hosted an HTML file in this link on a Google Drive, in most cases, like in our own case, we block most attachments from coming through our mail server or through our mail filter. HTML being one of those, because very rarely should you have an HTML file coming through your mail server. Unless you're a web developer or something like that, then you've got your own things. You probably don't use it that way. But I digress a bit on that. In this case, most of the time you can't have that, so we actually blocked. So how they've gotten around that is to make this. Actually, I'm going to grab a little highlighter here to make this a link that goes to Google Drive that downloads this file. So it looks like a PDF, but it actually is not in this case because I don't have show extensions turned on. This computer we're logged into right now, I'm remotely logged into. This is a disposable, a burner, a detonated computer. So what I've got is this computer is not my computer. This is a computer on an isolated network that only has it and our test machines on it. It has no access anywhere except to its local test network. It cannot copy files to me. It can't send them back. It can't touch anything. And when I'm done, basically I wipe this machine out. It's kind of like an idea of detonating the payload. So in this case, this is our payload. I don't run these on my own machine. I run these on disposable machines. In this case, we have this .pdf here. This is not a .pdf. If you mouse over a little bit, you see it's an HTML document. How they've done this is by default, Windows does not show file extensions. So a good practice is to turn that on. So you guys go to File Explorer and check file name extensions. Windows is just trying to be nice and make things look prettier. I think that by default, if you're one of our clients, we actually have a script that turns this on so that you can see these, so that people won't hide these things. Now we can see .pdf.html. So if you see the mouse going off the side of the screen there a lot, that's actually where I'm pausing so I can like cough and such. So just so you know. So we have our PDF here now, and let's just open it and see what happens. So we're in a system here where it's safe to detonate this, and let's see what comes up. So we have, obviously this is the file path, so it's on my test system, so we can ignore it, and we have our HTML. So this opens, obviously a PDF opening in, was this Chrome, so it's opening in Chrome instead of Edge like it usually does. So normally I would say opening a PDF in Edge or Chrome would be unusual, but unfortunately with some changes Microsoft has made where they want PDFs to open in Edge, that is not unusual. I would actually recommend in most cases these being opened in Adobe Reader just because it handles it better. I'm not going to say Adobe Reader is secure by any means. It has its own issues, its own foibles, but I think it's better than opening it in Edge. Edge tries, but it usually causes issues with like forms not working or formatting being screwed up or just a number of things where it's not the right way of handling it. So I always change that when I get a chance to. In any case, we have our HTML file that we've opened in Chrome. So we've got some sort of background here. It looks like an invoice. So what I think they're going for here, they're trying to say to view this invoice, they're more implying than saying, so to view this invoice, we have to log in. Okay, why? I don't know why we're necessarily logging in. So we've got obviously some old credentials I've been playing with on other stuff. So let's try something. Scam. Okay, so it's got some verification here. So what it's doing is making sure, let's see, just working for an @ Okay, no, it's looking for like the full, so looking for a dot. I'm just seeing how far the validation or the verification goes. So it's actually looking for, I don't want to screw someone's, actually no, it's not. Well, let's see, what happens if I actually put that in there? Does it care if I use punctuation or not? Okay, so yes, it does check for that. So I'm throwing some random characters in there just so there might be an actual test.com out there. I don't want to spam them. So scam at testblah.com. Next. Okay. So it actually is running through some basic verification, make sure this email address, it does not necessarily exist, but is properly formed in the user domain and tuple of domain. So look at our password. Actually, let's try something. 1, 2, 3. Okay, so 1 squared and 6. So it's actually trying to see if we're not going to like mess with like very basic stuff. Just give it just a bunch of letters and just a bunch of numbers. Okay, so it is incorrect. That turned around pretty quick. So I kind of doubt it's actually trying that password. We'll take a look at that in a little bit though. Let's see what we got here. So we got our password we tried. We mouse over these. I want to see what these links do. So if you can see in the bottom left, you can see where the link sends us. It's sending to .pdf.html hash or #. In HTML or web language, that is a location. So it's a way of finding a specific spot on a web page. So you can do, like, if you go to google.com, it takes you to google.com. If you go to google.com #, EULA, it will take you to a specific place on that page. So rather than going to a whole new page, it takes you to like a section of that page. So kind of like it's like an index sort of. In this case, both of these are sending us here. So if we click on, it won't do anything. So that's kind of something that you can. I wouldn't rely on that, but if you were if you actually got this far and you're like, I'm not sure this is right or not, I'll look at these and try to click and see if they work. I wouldn't give them details because this one is actually pretty well designed to where it's not immediately flagging off anything into me going, hey, this looks really bad. I mean, obviously, it is bad because we're looking at it. But I can see how the average person would be caught by this. If you're doing your job and you've got 100 of these coming through a day, you're like, oh yeah, this looks good. That's why you kind of have to have constant vigilance on these, because that's what the scammers are kind of going for. It's very rare to have what's called a spear phishing attack, where they are specifically targeting you or your company. The most attacks, I would say greater than 99% of attacks, are scattershot. They're hitting everything they can that's attached at all to their target or to just whatever they get their email list. So in this case, they actually sent from this lady's email address, Kathleen McMullen. So likely they sent to everyone in her contacts or everyone that she's ever emailed or something like that. I couldn't really guess. Well, I just guessed twice, so I can guess. But it's usually something like that. But that's where your vigilance comes into play of this person that sent me this scam. Well, they sent a report to me. They weren't trying to scam me. They sent it to me to look at. They very likely do business with this other company. So that is kind of like your sniff test right there. You go, yeah, this is entirely possible to be real. It came from a known vendor that we do business with. That vendor was compromised, so it's sending out these. And at a glance, this doesn't look half bad. I mean, it does. It probably matches. In most cases, the scammers will try to match the signature, the formatting, the color scheme, all that of these. This one, I think this is kind of more of a form or template one because I don't see like any logos or branding. Without talking to the customer more, I couldn't really tell you if this looks like what this person normally sends. I didn't really dig into it. They reported said, hey, this looks a little weird. Can you check it for us? That's something we're usually pretty happy to do. Where they'll email us and say, hey, this looks a little weird. Can you check it? Yeah, sure. No big deal to us. No, jumping back to this, a little bit of stream of consciousness, stream of thought there. Then you go and see, yeah, these don't go anywhere. That's a little shady. Privacy statement down here, yeah, it doesn't go anywhere. This is the hash, the bottom left, so that doesn't go anywhere. That's not a link, so we're not going to care about that. So unfortunately, I don't have an actual password to feed it, so we're not going to dig into that. It may not be necessary anyway. So let's see how this is set up. That's where we're going to dive a bit deeper. So in Chrome, you can hit F12, and it brings up this. This is your development tools. Though people think this is dark magic, this is really just a way. It comes built into Chrome and Edge. I think Internet Explorer has it. It comes in most browsers where you can go in and look at the actual code of the page. This is not hacking. This is nothing. I say it because there was a case where a judge or someone went after a newspaper because they claimed that the newspaper hacked their website and pulled stuff. They didn't hack it. It was just visible here. This stuff goes across the wire, across the internet, across the network, just like this. This is easily visible by hitting F12. This is not hacking. It's just looking at the code behind the page. It's not looking at the computed code. So like PHP and like .NET and a bunch of other languages. I'm not a web dev, so I can't dive too much into that. I'm cybersecurity side. So I know a bit of everything and not a lot about specific things. So what I'm talking about is when it does actual computation, something like .NET does, where it figures out like database queries, where it figures out how to do SQL contacts, where it's pulling things out of the database or moving across. I'm trying to think what it's called. Moving across different pieces of code. Those are computed on the server. was sent back to the computer, in this case what we're seeing here, or actually right here, this is only the HTML. So generally you won't have anything sensitive coming across this unless someone screwed up. So that does happen. That's where you do see someone has put like hard coded in a password or something into Java or something that is client side to where someone can pull this out of here. That is considered very, very bad practice. If we were auditing that, I would get an immediate fail on that. Be like, no, you never trust the client side. It's because you have no control over that. You really only have control, sort of, over what happens on your server. So like on a web server, it has control over what it processes, what the client gives it. And you can trust that, sort of. I would say sort of because you still want to have a fair bit of paranoia about that. There are things like cross-site scripting vulnerabilities. I'm blanking on some of his names now. Upward pathing. That's the one I'm trying to remember. I can't remember his name now. So basically, where you do something like, let's see, something like that. Actually, said what type of attack. It's when you're directory traversal. That's what I'm calling it. It's directory traversal, to where you don't trust what the client gives you. So you trust what's on the server, but you don't trust anything the client feeds you because they could be using cross-scripting or directory traversal to try to go upstream or out of the sandbox of the website. Or they could try to do like a SQL injection or any number of various attacks that are actually very easy to do based on something like the OWASP framework or just various tools out there that make this pretty easy. That's things I play with a lot, where I just work with these to see if I can hack my own stuff or to secure it. So a lot of the idea is you try to hack yourself to see how the hackers will do it, so you can better secure yourself before they do it. So again, stream of consciousness there. Okay, so looking at the actual HTML here. So we have HTML language, and HTML files. So HTML being websites. Well, website is a bit confusing. So Google is a website. Google.com is a domain. On Google, you will have a specific page. So like a search page or something. So that's the actual thing of like a book. Google is the book. Google.com is a title in the book. And HTML is an individual page in that book. If that makes any more sense or helps. In this case, we have HTML, or most pages we've broken down into two sections: the header and the body. So HTML saying everything on this page is HTML. So HTML from here to here. So a slash means termination. So when we see this slash here, that means end of section. So we have HTML beginning, HTML end. Head beginning, head end. So you see where it does this, it just truncated it, so I don't have to see it, just for ease of reading. We have body, begin, body, end. So let's look at the header first. Header is where it says basically setting up the page. CSS, cascading style sheet. Sorry, I blanked on what it's called for a second there. Cascading style sheet is what they use on basically every modern web page to set up to make it look pretty. Before CSS, you think of MySpace. Think of the hard times in GeoCities when websites were full of X-Files theme songs in MIDI formats and marquee blinky text, and it was a hard. The 90s were a hard time for us all. A lot of PTSD from the 90s for all of us. But CSS brought us out of that. There are the hard times that let us make prettier, nicer pages that can do cool things and make us look all professional and such. So CSS is part of that, though that usually lives in your headers. We're saying we're loading these things up. We don't necessarily want to show them because they're not in the body. We're kind of preparing to show things. So it's saying like our character sets are equivalent. So it's saying our character set UTF-8 is basically a way of telling it this type of text. This is the characters. So you can have multiple character sets. So like various languages have their own character set. UTF-8 is, I can't remember what it actually stands for right now. I'm not prepared for this, obviously. I'm doing this off the cuff. So UTF-8 is a character set. So this is everything we see on this page. Well, actually, like the page we're looking at right now, but everything we see on This page will be displayed in UTF-8. Oh, what we got here? Equivalent, so this is actually compatible. I'm not really great at that, so I couldn't tell you. Viewport, so meta and viewport content. So I'm actually, I don't know these, so I'm just looking at them to figure out as I go here. So viewport is likely our what we can see on the screen. So content width equals device width. Just scale 1. So my bet is it's setting our viewport is what we can see on our screen here. So it's basically setting the resolution or the size of the page to properly what's called responsive pages. So it's setting so it'll show on whatever device we're loading it on, an iPad, a laptop, a desktop, a cell phone, or whatever. These are all different resolutions. So like iPhones and Androids have different resolutions. iPads have different resolutions than iPhones. Laptops and desktops have different resolutions. Even same model of laptops have different resolutions depending on what type of monitor you're looking at it with. So what was taken here is just loading. I'm saying, what is my device width? So probably like in my case 1080p, and it's setting the width of the page to that and scaled to 1. So 1.0 means zoom 100% or just 1. And it's loading in some CSS. So Bootstrap icons, Bootstrap JS query. So these are actually very common. I see this a lot like the Bootstraps. I don't know a great deal about them myself. I'm not a web dev. What I usually see this for is they're loaded on basically every web page as a way of standardizing code. So rather than having to build your own CSS or your own formatting for your page, you can use, it's not so much a template as a framework. So think of like a grid work. This just helps you put things onto the page so that everyone else can, so that me as the web dev can, this makes my life easier. So from page to page to page, they all use the same sort of thing. So this Bootstrap JS is very common. So nothing surprising there. So CDN, so content delivery network, sorry, jsdeliver.net. So it's pulling in to npm. It is pulling in some Java here. Those are both pretty common from my understanding. So we might take a quick look at those in a little bit here. So we're just looking at the HTML for now. And title of the page. So our title is Microsoft Login. So what that means is title start, title end. What shows at the top of the page? So we have Microsoft Login here. Nothing special or unique there. I mean, other than that, obviously they're trying to pretend they're Microsoft, so I wouldn't call it unique, but it is annoying. So you get some styling here. So this is CSS styling. So they actually have loaded in this style sheet, like the standardized style sheet everyone uses, plus their own stuff here as well. This is not unusual. So you can override styles, or you can kind of layer them on top of each other. So you set the stage, and these are the window dressing on the stage. So we have like our stage here and our props on the stage. I'm not a theater person. I hope that made sense. So we're doing here. So each of these is an element of some variety. So dot setting. So we're telling whatever the setting thing is to center it, and we're making it 118 pixels. So I think this actually, if it doesn't have an element, if I remember right, if it doesn't have an element here, it applies to everything. I think that's right. So we're telling it. So you see like body. If normally you see like body dot setting or body dot something, that tells it to apply to that specific element. In this case, we're telling it this setting. This setting, we're setting everything to center. Our width setting is 118 pixels. With section 50 rem. I don't know what rem is. That's a new one for me. Alert SS display equals none. So whatever alert SS is, we don't want to show at all. What alert SS is? I don't know. We'll see if we can find that later. So we don't want to show that for some reason. And our body, so ybron.com auxiliary. So our background image. So our body, meaning everything we see on this page is a body. And so we're setting our background image to this. Let's see what that is. I'm betting it's just, actually I know what it is already, but let's prove that I'm right, because I like being told I'm right. Okay, so it's just this background. So this thing that's trying to make it look more legitimate is actually this background here. So we've got, this is being hosted at ybron.com. What's Ybron? So Ybron is potentially a legitimate company based out of, I don't know where that is. Ernaculum? Sorry, I don't actually know that country. Or is that a state? That's probably a state. Let's Google. Where are you? Central portion of the city of Kachi in Kerala, India. Okay. So it's like a city. Okay. Sorry, I'm obviously geography, not my strength. So where is part of a city? So Wybron Sales Corporation, second floor of this building, near the bridge. It's interesting. I don't know why they put like near the bridge in there. So Kalur, Kachi 17, curriculum. So in American speak, that would be like road. How is this formatted? Sorry, I don't know Indian address formatting. Let's find out. Okay, so country as it goes down. Okay, 17. So that's okay. So that's probably like that's the I guess the address. Can we just did I grab the whole thing? Okay, so pull it in. So number 17, Kalur on Kadavanthra Road. Sorry if I butchered that. I can barely speak English, much less Indian or Hindi. Yeah, whatever. Uh, I was listening to the recording. You can tell I have problems with English alone, much less other languages. So this site is hosting nastiness. So Ybron.com is hosting, at the very least, hosting the image we're seeing here. So that's concerning. So if we go upstream, I just want to see if there's anything else there we can get anything out of that. What's that doing? Let's do view, right-click view page source. It lets me see again what's going on here. What we've got. Not a whole lot. It looks like a loader. It's loader like just your normal spins like this. So I think it's intended just a spin. So I don't want to drive too much into the JavaScript here or the PHP stuff to figure this out because it's not what we're here for. But it is curious. Okay, so that's what that's doing. So we've got, going background, so our background is being loaded from this ybron.com page. I'm going to contact them again. Two people I need to contact now. Tell them, hey, you're hosting nastiness that could get you in trouble. So you've got a scam on your site. So we've got our head done now. So let's look at the body. Nope, I want to bring that out. And let's do expand recursively, so drop it all out for us. So we can see this is just, for now we're in the body. The body is actually all of this. Oh, wait, all of this. So everything we're seeing on the page is part of the body. So most of it is just going to be setting up how it looks. So I'm looking for anything that'll tell us anything interesting about this page or how the page works. So we got divs. These are dividers. So it's like breaking basically the page up into sections. So as we go deeper and deeper, it shows more specific elements of the page. So we see we have our form here. Well, not the form yet. Input ID, email, type email, required class. So that actually is, yeah. So that's where once our email address, and placeholder your email address. So when if we reload this, it should show. Yeah, so this is where this shows up. As placeholding your email address. We type it in, it'll take it out. Okay, so that's standard behavior. Oops. I think I accidentally, yeah, bring it back out. Okay, so that's part of the form. So forms being these. A form is, it can be broken up. You can actually multiple forms per page. I mean, forms are a way of organizing and handling inputs from the user. In this case, us. We're the client or the user for this page. So it's a way of organizing this information so that it doesn't, like, you don't get this as part of your form. You're only asking for the input as part of the form. So it's doing, so password div, email div. Okay, so we've got this, all of this is part of the email section, so it's requesting our email address. And we have password div, that is where it's requesting a password, so everything from here, down to here, these is the, where it's getting our password information. Okay, so we'll be getting interesting in here. Password 1, type password. So this is a standard input. Input is wherever a user or a client can actually enter data. So we got input password 1. It's doing class, where it says class equals some stuff. That is where it takes, these are basically stand-ins for CSS. So saying border secondary, it's saying if this border secondary will show up somewhere else in the CSS. So it's a way of placeholding for like how you want the border to look. Do you want it to be thick? Do you want it to be dashed? Do you want it to be a certain width, a certain length, a certain color? Those are placeholders, so you can, instead of typing that every time you use this element, you type it once in this border secondary, then modify every time the element shows up. It's not so much lazy as efficient and a good way so you don't have to modify this over and over again 100 times. You can just modify this single element in the CSS and it applies everywhere this is invoked. No, in case we got password enter password, so nothing, placeholder enter password, nothing new. You get button ID. So the actual submit button ID is the submit button. So I guess in this case next, but so what it does. Actually, okay, I see. Okay, I got you now. So button ID, next button, submit, on click, show hide. So what it's doing here is when we click on this next button here, if we type something in and click next, it's going to run this piece of code here. So on click, so when we click it, run this show hide. So generally whenever you see like parens like this, that means it's opening a function. So a function is a bit of code somewhere. It's I'm trying to think how to describe functions in a way that makes sense to you and to myself. Functions are basically prepackaged bits of code that you can invoke multiple times, or as many times as you want. So you can pass it variables. When you can put them inside these parens. So that's where you tell it, for the function show hide, I'm passing you a username, a password, or whatever. If it's blank, it generally just passes it whatever's in the form or nothing, depending on how you've got it set up. In this case, anything that's in the email, in this input ID email 1, will be passed this show hide function. So we'll make a note of that. We'll put a pin in that real quick, and we'll find out how that works in a little bit here. Now, my bet, though, is this show hide function just hides this email section. Because something to note on this is we're not actually talking to a server right now. So normally, if you were actually doing real authentication, you would send this email address or your username to the server to authenticate or to just check. It wouldn't necessarily be a full authentication at that point. You don't want like a one-point authentication because I would check your email address and you're good, right? Like, no, you want a username and a password. So it can't do that right now because it can't talk to a server. This is all self-contained. So it's going to be doing this through likely Java on this page. So Java is JavaScript is a client-side function. So instead of running on a server somewhere else, you can actually run it inside the browser. I'm not a huge fan of Java, actually. Big reason for that being I think Java has some major security issues they kind of work out. And it's just used in a lot of attacks like this. So anyway, So we hide when we type in this, obviously we've already seen us do it, but what we're learning here is from this section, from this email division, when we click the next button, it probably checks if there's something else there or not, and hides it and shows the password section instead. So let's look at the password section. We have actually looked at it a little bit already. So we can add access to our password. And if we click submit again, it goes to verify. I assume it's supposed to be verify, but verify. Let's go with that. Now again, it hands off this information to a script of some variety, and it's got nothing else. So it's not passing off to another page yet. So a lot of times you'll see it with a form. Do we have a form section here? Normally you would see a section like a. I'm just trying to see if I see like an open form. If you all see it, you can probably go ahead and tell me I'm not seeing it. So you usually would have a form element in here telling it where to submit this to and how to package the data. We're not seeing that here, so it's not handled that way. So interesting, but it makes sense that they're trying to contain all of this on a single page without sending anywhere else because there's nowhere else to send it right now. So looking down, we have what's called our footer class. That does not mean it's actually a reserved class. So you can have reserved classes like HTML and body. Those will always be HTML and body. You can't really have a page without those. So a footer class is something they've named footer class, or footer with this class. So our footer section here, background color, something. So I bet, yeah, that's a bottom section down here. So it's this stuff down here. And as part of that footer, okay, so yeah, it's just a bottom section. So it ends there. So it's just a bottom section. We don't care then. We have some scripting loaded here. So script source. So script src means source. So we're loading in something. In this case, looks like we're loading in some jQuery. That's basically a pre-packaged Java query module, and some more Bootstrap. So that's the minimal bundle for Bootstrap. So yeah, they're just reusing some pre-packaged assets that are available widely on the internet. So these are a bit more interesting here. So these ones I haven't seen. So smtpjs.com version v3, I assume is v3, smtp.js. So SMTP Simple Mail Transport Protocol. That is used for sending mail. So that is somewhat interesting. Sorry for a quick pause there. I forgot some of my notifications were open there. I had to close those. I thought I got them all because I'm professional, obviously. Okay, so SMTP Simple Mail Transport Protocol is used for sending email. So basically, mail from a user to a server and from server to server. So it's not received. Well, I don't want to make that confusing. It's not used for receiving mail like POP3 or IMAP. It's used for sending mail. Obviously, you're going to receive that mail, but it's used for communication of mail, not reading mail, if that makes more sense. I unfortunately have some problems explaining concepts very well sometimes. So smtpjs.com, what is that? I suspect it is, what are you? It's a mail from JavaScript. Okay. So it is a prepackaged mail, it's prepackaged code for sending emails through JavaScript. Well, that's interesting. So what they're doing is they actually have packaged up this page enough so that I can actually send mail. I wonder if that would get around. Like in our own case, we block port 25 is used for SMTP. So various services or communications require certain ports to be open. So like website is port 80. A secure website, SSL HTTPS, is port 443 by default. Mail SMTP is port 25. DNS, so like asking whereas Google, to get to the web page, DNS is port 53. So each of these services have a port designated to them. SNTP, in our own case, we block all outbound SNTP except for from specific servers. So that's kind of that's a way internally we prevent mail from coming out. Like if somehow a computer is compromised from it sending mail, you can only send mail like on our own network from this specific mail server. So I am curious if that would work here. Like if we did that, would this actually block this? Can we take a look at how this Java works? It's probably a lot more. Well, I thought it was going to be a lot more than it was. Let's see. So send. Actually, no. Go back. It's going to be easier to read sources. I thought it was going to be easier to read. Reload on that. Sources or network that I'm looking for. There we go. That's trying to make it nicer or easier to read. I didn't want to take apart all the formatting and the tabs and all that. Okay, so this JS script. Though it's actually fairly basic. So variable, so var means variable. Variable email is equal to basically everything inside this bracket. So everything in here we're setting as the variable email. Inside this variable email, we have individual functions being assigned. So send function A, Ajax. A is not actually a function itself. That is likely a variable placeholder. So for the send function, we can accept variable A. And the Ajax post function, we can accept the variables E, N, and T. Ajax, and we can set the functions E and N. Well, not the function, the variables E and N. Sorry. And create CORS request, we can accept for this function, we can accept the variables E and N. So we got a function for no cache. So it's basically turning up the cache. It's telling it don't cache. Okay, if I'm following this right, it's setting the cache for this page to not cache. I think for a very high number. 1 to the math random. Math is not. I'm in security, not in math. So that's a problem. Okay, and action equals send. So when something is passed to it, it passes it to, makes it no cache. Action equals send. So we're setting the action variable to send. Variable t is equal to JSON stringify a. So whatever we've passed this function in the a variable, we are stringifying it using JSON string. JSON is, this is actually near the limits of my knowledge on this. It's a way of communicating, I think similar to Ajax, if I'm right. So it's I think they're used pretty not interchangeably, but they're used together a great deal of the time. It's a way of being able to show live data on the web page without having to reload it or resubmit it. So like, as I know, if you go to like Google and you start typing stuff, it immediately starts showing stuff like other users looked at this. That's JSON and Ajax. Because normally if you go to like say on this and you start typing stuff, it won't submit this data until you click next. But if you go to Google, I'm sorry, on Google, so I'm not sure why I did that. But as soon as I start typing stuff, see how it does, it automatically adds stuff there. That's JSON and Ajax. So it makes it so that it will immediately start loading, basically submitting as I type rather than submitting when I click submit. Okay, so it's stringing it. Basically, it's probably taking some complex information, in this case, like a username and password combination, and putting it into a string. So instead of being username and password separate, it's making username and password one string to make it easier to send. And then it takes that and takes the email Ajax post, so our next function down here, and passes it some stuff. N, E, and T. And so our function Ajax post, so we're basically invoking Ajax post from this other function. So Ajax post creates a course request. So in this other function here, we're requesting this function as well. So you can embed functions or have functions request other functions. Course request, I know the name, I don't know what it does, but it's posting. So it's sending data, in this case E, somewhere else. E probably means email if I were to guess, without diving too deep into this. We're already deep diving, so I don't make this 3 hours. So we're not going crazy deep. We're going, not over our heads deep here. So it's making this request. So it's posting this request. So XML HTTP request. So XML is another way of formatting data. It's I don't know how to describe that without actually showing it. So let's do XML. So XML is XML, not XM. So XML looks like this. It's okay, not where I wanted to be, but here we go. This works. So this is XML. This is a way of formatting data so that it can be read easily by computers. Generally, only computers. You wouldn't want to read it on your own. So it's a way of basically making cascading or not embedded, child or sub data. So you have your main data or your main entry and your sub entry and your greater sub entry. So parent-child relationships there. So they're doing something there with an XML request. Return with credentials in T open. So this T is opening something if it's not 0. So exclamation 0 means most likely means if we get back not 0. Defined is not equal to. So exclamation equal means not equal to. So a lot of times, actually, easier to read this from right to left because of the way it handles its order of operations. But this is probably too big a thing for me to figure out. Just because I don't speak this, I don't normally work with this. Type of domain request query. So we got a sub section here. T new domain request open en. So T equals null. So it's probably processing is left to right, if I were guessing, which I am. So variable T is equal to new XML request. Return means whatever we do here in this section is going to be returned to whatever invoked it. So in this case, email requested us to load Ajax post. Ajax post is to request course data, and course data is telling us to do something, and we're going to return back to that and back to that this information. And then it just sends it. So when we break it all down, what this is actually doing is taking the information that we pass it, in this case using password, packaging it, and sending it using SMTP. I was kind of wondering if it was sent through port 25 so that we could block it through using a firewall, but I don't think using this. So what I'd likely do, I just block smtp.js or smtp.js.com at the firewall, unless there's actually a need for it. I mean, there might be a legitimate need for some sites to do this, but I can't think of anything offhand. Like, I would probably err on caution and block this, which I likely will do for ourselves at least and for clients. And if it comes up as an issue, we can reopen it or reevaluate it. A big reason for that is I'm wary of any time email flow is going without going through the actual server, through like your actual mail server, so you can control that mail flow. Because this would be concerning. Like if you have something able to send mail out of your network that you don't know is there. Okay, so let's look at Mailjs. So this is doing. Oh, we got a couple different pieces here. Okay, so function send mail. So email send. So somewhere I probably missed it. The send email function is loaded when. Go back over to elements here and show me everything again. Expand recursively. The likely part of this form. So verify. Okay, so here we go. So when we do password, we type our password in and click the submit button. It loads verify. So we go back over to here. Actually, over here because it's easier to read. We have our function verify runs. In this case, it looks at our email and password. So it's loading these. So it's saying on this document. So on our web page. Sorry, I had to pause there again. We have an office Roomba named Robbie, and he just woke up, and so he started driving around making noise. So I had to tell him to go back to bed. Okay, so document means this web page. So on this page, get by element ID. So we're looking for a specific element ID called email display, and we're looking for text on that or a value. So I actually don't know why they decided to do inner text and value differently. I would think that value would work for both, but likely is a reasoning for that. I just don't know enough to tell you one way or the other. But in this case, what they're doing is in this Java function, get the email and password we entered as part of the verification. So if password length is less than 6 and the password does not equal blank, then do this. So get LND alerts, flex, password should be greater than 6. So if password is too short or is blank, it tells us we need to make a password that's longer than this. Else, if password equals blank, password cannot be empty. Oh, password does not equal blank. Sorry. So if password length is less than 6 and not blank, so 1 to 5 essentially of password length. Yeah. So if it is straight up blank, then password cannot be empty. Else, so we've checked if the password is too short or does not exist. If it does exist, we're pulling a send email and we're passing the email and pass. I like how it's something I do like if I click these is highlighting every time those are shown. So our send email function, which is shown up here, is being passed, the email being read here, and the pass being read here. So what's actually, and after that, once it passes your credentials to this function, it just strips as your account is wrong. So that's how they're kind of getting around actually checking it. This is lazy. I'm most poor in this one. I've seen some pretty good ones where they will actually do like a man-in-the-middle proxy, where they will send your credentials actually, you'll go to their site and they'll send your credentials actually to the Microsoft login and check if it actually works before they tell you to go away. This one is just straight up telling you it doesn't work. So I'm kind of disappointed in that one. I mean, this is good as far as containerizing and making this portable. So if you're trying to get around various filters and all that, simple is sometimes better. Because the more complex you make this, the more complex you make your attack, the more likely is someone like me can find a specific element of that and break it. Like I may not get your entire attack or kills chain, but I don't need to. If I can get an element out of it and break that element just by luck, or hopefully by skill, but if I just get lucky, and I've written this code where I have tried to prevent this from someone else, and your chain uses the same attack as someone else, then it fails. Whereas if you keep this pretty simple, like they're doing here, it makes it, I wouldn't say more likely to get by, but at least it's not going to caught by other stuff. It's that kind of balancing thing. I mean, they're making it simple to where they're hoping that someone types the right password in here and not like screws it up 3 or 4 times like I do before it goes in. And although, and kind of thinking about it, people use password vaults now, so that's copy pasting their password straight in. Then they're kind of going, "Hey, I typed it in; it's going to be right," but it's going to say it's wrong. So that would throw some flags up to me. So they're scripting it. It's immediately, as soon as you type a password, no matter what it is, right or wrong, it's going to say your password is wrong. This is where 2FA comes to be very important. No, 2FA is not the be-all, end-all magic pill for everything. What it does is if you do get caught by this and you give these people your username and password, they still can't do anything with it because you have a 2FA code. That's usually if you're using something like Duo, Duo is amazing, where it will either challenge you by sending a thing to your phone saying, "Hey, do you want to allow this to happen?" Or it will ask you for a 6-digit code. 6-digit code is actually the most common. I think it's called the RSA key style, or a TOTP, a time-based one-time use password, TOTP. So you have different ways of doing 2FA. Those are the two most common that I've seen. But yeah. So that kind of helps this, or it doesn't just kind of helps. It prevents it entirely without them getting that code as well, which is outside the scope of what they're trying to do here. So they kind of fallen down on that, where their attack is simple, but if they don't get that time-based one-time password, or in my case, like my Duo authentication or the 2FA MFA code in general, this doesn't do them any good. I mean, it's still bad that your credentials are out there. You don't want that, but this saves you. So kind of like you've fallen off the ship, but at least someone's there to pull you out of the water. I mean, it's rather than the sharks being down there. Like, okay, yeah, I've tripped and fallen over the rail, but I still have 2FA. So someone's quickly said, "Oh no, you're safe. I'll pull you back up." Whereas without 2FA, you're kind of like, "Well, I'm an Aquaman now. I live here." Back on topic. So send email. So what it's doing is we're pulling this function send email, and we got it up here. So it pulls the email pass, as we saw down here, and sends it. So email, as we saw over in SMTP here, so this email, all of this is read by this, and we do send. So send is this function here, which we saw earlier, flows down through these, and sets up these variables. So this is actually interesting. So like I was saying earlier, something I don't like with Java, and a very bad idea, is to hard code your variables, because you can never trust what the client is doing, what the viewer is doing on your whatever they can see. They can obviously see. In this case, they have hard coded their username and password into this code. That means I can see it. Obviously, I can see this right now, so you're seeing it with me, assuming you're watching this. And if you're not watching this, then how are you hearing this? Interesting. So we can see this is sending through host to smtp.gmail.com. Username, this is their username. This is the password for this account. So something of interest to me is it doesn't use a port. So that is probably something, again, I mentioned missing it. That is probably handled. Okay, I see how. Okay, gotcha. So it's getting around the port 25 block by, instead of sending it through port 25, it's sending it to this page as a data packet, and then it sends it for you. So if I block, I mean, for me as an incident responder or cybersecurity, if I block this page, this attack fails. It just won't work because it won't have where to send to. And on the plus side too is I can also, because I know how this works, I can go into like my firewalls or my filters and tell it, anytime we see this being invoked, I can make an alert. I can block it and alert, so I know that someone has fallen for this attack. Over here, someone has fallen for this attack. So I can block it and tell myself or alert my team, hey, something's gone. Someone's done something here. In this case, for Gmail, log in with these credentials and send email to themselves, to the attacker selves, whatever. So from GenTV2 to GenTV2, subject email from Mailjs 365, body, we got the password. So basically what they're saying is send an email to ourselves, the attacker, we got these people's email and password. That's all this actually does. So we spent an hour basically digging into this. So what's actually all this is doing is when you go in here and type your username and password in. It does various bits of wizardry and such to send an email to this email address with those credentials. It's, I could call it elegant. It works. I mean, it could work. If someone like me is not going, hey, I see you there. You're a bad person. Let's stop that. We're not doing that crap today. So let's try this. There's a Gmail address. We have their password here. Let's go to Gmail. Gmail.com. Oh. If I can type. Gmail.com. Sign in. Don't get our hopes up yet. Password. Give me that password. Oh my god, am I a robot? Is that an O? Or 0? Let's hope it's an O. O-V-U-S-T-A-G-N-O? Yes? Maybe. S-U-R-T-U-B-E-R? Oh, I might be a robot. S-U-R-T-U-B-E-R. Next. Okay. No. Oh. I don't care if I show their password. They're scammers. Screw them. Next. Okay. So they've likely changed the password, or Google's already shut the account down. I'm not sure which from here. I would assume Google shut the account down because if they change, this is kind of a flaw in their approach here. Well, a few different flaws, but our flaw right now is if they do change their password, this attack no longer works because of the way they set this up. Because this is a containerized portable attack, once they send this out into the world, they can no longer change this information. So once this email goes out from wherever it comes from, this password is hard coded into this web page, into this HTML file, so that if they change the password on a Gmail account, this will fail. And that's what's happened here is either they've changed their password because people like me have been screwing with it, or people like me have contacted Gmail and said, hey, this is a scamming website, or Gmail probably figured a scamming email address, or Gmail figured it out because Google's actually pretty good about detecting that sort of thing. So in the end, their attack has failed. They spent a fair amount of time probably setting all this up and sending it out, and they screwed up because it didn't work. I kind of wonder if they actually got any people's credentials. I hope not. I don't like that, and it bothers me if they did. But my bet is that Google shut them down pretty quick. Google's good about that. If not them, then I would have requested Google do it. I might still do that. I might send an email to Google still and say, hey, you got a scamming page on there. But so we're coming up to, actually an hour and 3, depending on how much I edited this. So this is a deep dive into scamming in cybersecurity. I've kind of showed you how this attack works, where someone's account was compromised and they were sending out this email with this attachment on here that we looked at over here. So we look at this attachment, not a PDF, actually an HTML file, and how you identify that. And when we look at this at the HTML file, the web page, we get this and how this works. And we kind of dove into, we actually did dive pretty deep into how this code works and how it falls down. And how to protect yourself. Some good ones, blocking port 25 from anywhere in the network except for your actual mail server. If you use an internal mail server, that's becoming less and less common. Blocking JavaScript, blocking HTML from coming over. You can't block it from being sent, but you can block it like from your firewall, but you can block it from coming through your mail. Being aware, being hyper vigilant even of things like this. 2FA MFA is superpower for this. Compartmentalizing your passwords. This would it wouldn't save you from this, but it would help. So the idea is you don't want to recycle passwords. It's a bad habit if you use the password on this, like you have your favorite password. I love this password, it's the best password ever. It is so secure, you wouldn't believe it, but I use it everywhere. So if that favorite password of all time is compromised, they know your password everywhere. and it's called password spraying, where they've compromised your account, or they've somehow gotten that password from a database compromise from some other company you do business with, or you download from, or buy from, or whatever. That password was got. They will go to the email address, usually with your password on that service. They'll try it, and then they'll try it everywhere else they can possibly imagine. So that's why you want to have different passwords for every service. That's where you use things like password vaults when 2FA and your password vault. So if they do get your password and your 2FA or something, it limits the damage. So that's risk mitigation or damage mitigation at the very least. So if they said they did get your password, at least they only have it for this service. I mean, if it's your email, that's still not great. That's if they have your email password and they're able to get into it, that's still not great because they can still use that to leverage or to pivot off to other services that use your email as a password reset method. So you don't want that. But that's why you want 2FA on top of that. So it's layered approach. Security layers, like as Shrek's is, we've got layers. Onion's got layers. Security's got layers. Shrek has layers. You don't want to rely on just one method of safety. Kind of like driving. Your seatbelt's great, but you still want to drive safe. You may not be like doing 90 miles an hour on the road. Go, I got my seatbelt on. Seatbelt doesn't help if you plow into a gas truck and explode. You want to have your layers of, I've got my seatbelt. I'm being cautious. I'm doing a speed limit. I'm not going head on into that gas truck, Terminator style. You just want to make sure you have all these things in place so that it makes the life of attackers and scammers harder. And the harder we can make their lives, the better, because it disincentivizes them to doing things like this. The more effort it takes for them to do these things, the more likely it is for them to get caught, and then the longer it takes them to recover from it. And it's that cost benefit. In scamming, their cost is very low. Saying like this attack out, it probably took them, I'm gonna call it 2 or 3 hours to build this attack. Now that they've got it sort of worked out, they can send this over and over again. So they've packaged, they've commercialized, commoditized, I guess a better word, commoditized this attack. They can reuse this over and over again, because nice thing and the bad thing, well, the nice thing and the annoying thing in this case with computers is you can reuse that code a billion times. It does not care. So now they've got this, they can keep on reusing it. Just be aware of that. I think that's all I've got. Now we're an hour and 10. Geez. If you got any questions, or if you got anything else you want me to deep dive into, I'm happy to do that. I love this stuff. Cybersecurity is so much fun. Give me a call, 888-526-1631. John Miller, Internetic. I'll see y'all around.